we may be able to turn it up or turn it down. But how do we know how far? Can we track that?
Come all you moonshiners if you
Yep.
want to hear about the kind of booze that they serve around here. Made way back.
Welcome back to Barley and Hops. I'm George, the channel that's daring to unlock the mysteries of home distilling. If you get an opportunity, of course, subscribe, share us with your friends, comment below. We welcome all comments and spend a lot of time reading. So, on to bigger and better things. Now, we already know that we can control the amount of voltage and amperage that goes through this light. Well, we can turn it all the way up or we can turn it down, so we can control that. But what we don't know is we don't know the value. We don't know how much of that. So in essence, if you have a potentiometer, short of drawing lines for where you think its value is related to temperature, you really don't have an idea of how far it goes to, So can we measure that? Absolutely. And we just put a meter on that and we'll measure that. This will probably be, mark my words, this will probably be the most important video you ever watch about electricity. And I'll share with you why. Once you understand this, because the principles are going to be laid out real simple, once you understand this, nothing will escape you. We have two options, okay? The two options are we can use a digital multimeter, volt amp meter, or we could use an analog meter for those who like to use the one with the sweeping arm. This is known as an analog meter. And this one's known as a digital meter. It has a digital readout. That's really the only difference. But they both do exactly the same thing. And based on their rating and the way they're designed, they do it just a little bit differently. But they're measuring exactly the same thing. Last but not least, and we'll do this, we'll test it. I've got a multimeter here with an amp clamp. That's the clamp at the top. Some of you may even own one of these and have no idea what this clamp is for. It's not just for hanging it so you can read it. It actually serves a purpose. And we'll explain that and we'll show you that. Because what we do know is we do know that as voltage runs through here and illuminates our light, what is actually happening as well is there is an amperage value that goes along with that. So we just like to know what that is. Now, we know that a 2,000 watt element on 120 volts, and that is wattage divided by voltage equals amperage. That's how you kind of figure that out. I believe it's 2,000 divided by 120 is like 16.9, which means that an element running at 100%, if it's rated at 2,000 watts on 120 volts, will only draw 16.9 amps. If we reduce that voltage, we reduce that amperage as well. But it'll never draw more than what it needs. Here's the key point behind this video that's going to unlock the world of electricity. Your amperage is totally dependent. Now remember this, totally dependent on the requirement of your load. Wow. Yes. If your load requires 16 amps of electricity and you're providing 100% power and you're providing that through a 40 amp solid state relay, that only means that the relay can handle 40 amps. But you'll never have more than 16 amps that go through this line. The load, it will never exceed the amount of amperage that the load requires. If this load is only, let's say for instance it's a light bulb, and it only requires like 0.2 amps, and you run it through a 40 amp relay, there will never be more than 0.2 amps that run through this line. So you'll never have more amperage in the load than what the load requires. That is the first step. Is that not amazing? So it doesn't matter. I mean, you know, a lot of people, when they say, well, I'm just going to put a 60 amp in there because I want to make sure I can. No, a 60 amp only means that this controller, this piece of equipment here, this solid state relay can withstand that amount of current flow. It doesn't produce it, and it doesn't send it through unless it is required. I'll demonstrate that. Now, the first thing we're going to use a multimeter. Where are we going to measure amperage? I'll give you a few seconds to figure that out while I grab my marker. We're going to find that out. We can measure it in one of two different places. We can measure it around this line, or we can measure it at this line. Either one, but not both. Only one, because we want to know the current flow through the circuit. If you test it between both of them, they cancel each other out. Okay? So we know that through a circuit and through AC current, we have this sine wave that's going through. It's got positive, negative, or high, low, high, low, high, low, high, low. And that creates, it's called the electromotive force. And that creates a magnetic field that it expands, contracts, expands, contracts, expands, contracts. And if we can measure that, because there's a formula for that, of course, if we can measure that, we can tell how many amps of current is flowing through that conductor. That's what we use our multimeter for. Let me get you a close-up and show you this. So this is the amp meter that I'm using. And all amp meters are a little bit different, but this one has a wheel. Then you have selections. You got 4 amps, 40 amps, 400 amps, voltage, whether that be AC or DC, ohms, hertz, and then non-contact voltage. With that non-contact voltage means I can test this. It'll tell me if there's actually current running through the wire. I'm going to go down to the lowest one, which is 4 amps. And what I'm going to do is I'm going to measure, you see I've got a ghost reading here. What I'm going to do is I'm going to place this clamp, this is the amp clamp. I'm going to place the amp clamp around the current carrying conductor. And that's this one, the one that's going to the brass screw. Now I could put it around the neutral. It's totally up to you. It doesn't matter. You can put it between either one. But I'm going to wrap that around that current carrying conductor, only one of them, and then I'm going to turn the light on. And as I turn the light on, when the light starts to illuminate, you'll notice that my amps will start to increase. Whoa, let me back them up. There you go. 0.917 amps. It'll fluctuate around. It's pretty sensitive. And as I increase the flow, you'll notice that my amperage increases. So I'm at 1.310, somewhere in that general area. Okay, now what happens if I clamp it around both the hot and the neutral leg? Well, look at that. I get a 0.079. They start to cancel each other out. So you get a false reading. You see that? You get a false reading. Now, I could put this around the neutral line and I get the same reading because the current is running through the main and all the way back through the neutral. Now, what about running that through? What if I put it at the beginning? If I put it in front of the solid state relay? Well, I get the same reading, because this is measuring the current that's running through the line. And remember that your load controls how much current actually runs through your current carrying conductor. I could put it here and I get 1.318 at that point. 1.339. They're the same in relative terms. Well, that begs a bunch of questions. Let's unplug, because we know that this only draws this 150 watt light. Is that 150 watt? I believe it is. Yes, 150 watt light bulb. It only draws 1.3 amps. let's plug in my heat gun. And I know that my heat gun has a 1600 watt element in it. I'll plug it up on top. It doesn't matter. And now I'm going to show you something. The only thing I've changed is the load. The load on this circuit is the only thing that has changed. I've left everything else to be the same. And I'm going to place my amp clamp right there on the load carrying conductor. Let's get a close up and show you how that works now. Now, as I turn this up and my heat gun comes on, it's OL, overload, which means it's drawing more than 4 amps. I need to change the value setting, so I'll go to 40 amps. Now let's check it. There's 6.9, 6.8 amp, 5.8 amps. And if I increase that, the more I turn it, the higher my amperage runs. Now I'm running at max power, full open. This is running at 11.6 amps. Somewhere in that general area. So you say, oh, well and good, George. Well, okay, so that's what that draws. Well, what if you put the light on too? Won't the light draw 11 amps? No. Remember, your current is controlled by what your load requires. Let's plug in the light. Let's do this again. Now, as we turn it up, I've already got 40 amps selected. And we start to turn that up. Now, both things are going to take place. My light's going to come on, and my heat gun comes on. And as I turn this up to full power, now if I put 13 point, okay, we'll call that 13.3. If I put 13.3 amps through that light bulb, trust me, it would explode. So the light bulb, they're both on the same circuit. The light bulb's only drawing what it needs, which is I can't remember now, is what, 1.6 amps, 1.3 amps? And my heat gun is drawing everything that it needs, which is 13.3 amps. So that's working. And as I turn it down, you see I can adjust that. There's 5 amps. So just so you don't think that I'm trying to fool you, I've got them both hooked up. They're drawing separate amounts of amperage. Remember, if I put all that amperage, my amperage to that heat gun is totally dependent upon what that heat gun needs. And the lower amperage required by that light bulb is totally controlled by the amperage that light bulb needs. It's not going to get any more. So that's what I was talking about being probably the most important principle to understand about the flow of electrical current. Again, controlled by the load. Now, so how do we control that, or how do we read that? Remember, we could use our amp meter on our amp clamp. We know the amperage, but we don't know the voltage. We can use an analog amp meter that tells us just the amperage, and I'm going to wire that up, I'll show you. Or we can use a digital volt amp meter, which tells us both the voltage and the amperage. But how do these two fit inside that circuit? Well, all we got to do is find a place to put it. Remember, where do we want to measure, or where do we take our measurement? We take our measurement, let me erase this. We take our measurement around the load carrying conductor. So we've got one or two options here. On the back of an analog meter, there's 2 posts. There's an in and an out. And you run it into one side, you run it out the other side. So what we do is we just make a break here. And if you don't mind, I'm just going to erase this potentiometer because we don't need that anymore. So we make a break here, and on the back of your amp meter, there's 2 poles, and they're located back there, but here's your sweep needle. And we're going to run one of them to one, and that's in, and then we're going to run the out to the other one. So that means that the load that comes through that line goes in one side of the meter and gets measured and displayed with this sweep arm, which tells you what the amperage is. It goes back out to the load. That's one way of doing it. All right, and that's as simple as, let me show you that. So what we're going to do is we're going to interrupt the circuit. Where do we interrupt the circuit? We're going to interrupt the circuit at the number 2 pin, because that's where it's going to flow from, and it's going to flow to our receptacle. So what we'll do is we'll put a jumper wire. We're going to run this. You see this is the sweep. So we got a pin here, and we've got one here, electrical connectors, 1 and 1. So we're going to run one into this connector here, which is on this side. It's going to go from this way to that way. It's going to measure it. So I'll attach my little pigtail, or my spade is what they call them, there. I will unplug it, because I didn't do that earlier and I got a shock. I'll unplug that. I'm going to remove this lead. And I'm going to place that lead on the outside outpost. So now the electricity has to run through this meter in order to get to that receptacle. I'm going to leave that set right there. And then where does this one go? This one goes right here, which is going to be the current and the voltage coming from my solid state relay to my receptacle, which goes to my light. So watch this. If I plug this back in, now how many amps was drawn by my light? 1.3, 1.6, somewhere in that neighborhood. I mean, it was a really low amount of amperage, and that was even at full power. I'm just going to turn this straight up to full power. Maybe you can see that needle. Just barely. You notice that? It's awful hard for that analog meter to measure, because it's graduated from 0 to 20 amps. It's really hard for it to measure just less than 2 amps. Now I'll plug in the heat gun, and I'll do the same thing. Now watch what this reads. Because you notice that nothing in the circuit has changed except the addition of another load. So now it's measuring, and that one is measuring almost 13 amps. And that is my analog meter. And oh, by the way, just for those who have one, it comes with a small screw head right here. And if you turn that screw head, that changes, or that zeroes out your needle, so you can adjust it if it's a little bit off. So that was using the analog meter, where we have the current running in and running out and being measured on a meter. Now remember, we talked about this. What does current do in a current carrying conductor? Well, it's an electromotive force. So it creates a magnetic field that expands and contracts, and we can measure that. And we can measure that and convert that to the amperage, because it's proportional. And how do we do that? We put what I call the donut. And this is just a small piece of metal with a whole bunch of wire wrapped around it. And that picks up the change in the magnetic field around a current carrying conductor. See, it's just a small circle. It's got 2 wires that run off of it to measure. That, in this particular case, we take this out. This line remains solid, and now that donut goes around one conductor. And then the 2 wires come off of that, like that, And there is your digital multimeter. But what do we need to make a digital multimeter work? We need power for it, okay? In this particular case. When it comes to an analog meter, your needle swings based on the amperage that goes through the meter, but in this particular case, we need power to make this work because it has to do two things. One, it's going to measure voltage, but it also has to do with a small circuit in there that has to calculate amperage. So we need power. We're going to need a hot, and we're going to need a neutral. Now, where we take this from, it does make a difference. Okay? It does make a difference because you want to know what the amperage and the voltage is at your load. Now, can you take it from the beginning of the circuit? Absolutely. But what happens when I do this? What happens when I run my neutral to here? Uh-oh, this one now is a neutral. This is no longer 120. It's not a 240 volt circuit, okay? If it was a 240 volt circuit, it's wired the same way. So this is a neutral. And if I wired the other one to this, what will this meter tell me? This meter will tell me the amperage at this point, but it's going to tell me the voltage at this point. Okay? And I want to know the voltage at this point. Right? So because the voltage going to the solid state relay is going to be 120 volts. So in practicality, and again, it doesn't really matter, but in practicality, what you really want to do is you want to take your voltage leads or your power leads as near your load as you can get them. No, not as you can get them, but as near your load as practical, okay? Which means that this lead I would take from here, and this lead I would take from here, or anywhere in the circuit. But I want to be able to measure the voltage that's going to my load. Well, let me show you that. Now there are various types of meters. Some will just have voltage and amperage. This particular one, this one runs about 18 bucks. It has volts, amps, my goodness, wattage, power factor, kilowatt hour. So it does a lot more. But a volt amp meter is adequate enough. Now we have, you see, we've got the donut, and the donut's already wired. All you have to do is follow the schematic on the back. It'll tell you exactly where to put the wires. Now, so we're going to put this donut on the current carrying conductor. Which one is that? That's the one that comes from the number 2 pin to the receptacle. And we're going to insert that through the donut, and we're going to reconnect that to our solid state relay. Bada bing, bada bang. Now I need power. Where do I have power? Well, I've got power at my pin number 2 because that's the voltage I want to track. I could track it from pin number 1, but it would always read 120. And I know that I'll be controlling that, and it won't always be 120, but it will always read that because I'm picking it up from here. I want to pick it up from the output. So I also add a connection to that 120 on pin number 2. And then last but not least, what do I need to complete that circuit? I need a neutral. There's a small screw on the side here. It's a silver screw. And all I've got to do is put this spade connector on that screw, and then screw that down. Oh! Yep, there. Remember, you've got to disconnect the damn power, or... Okay. 120 volts doesn't hurt, but it does make you let go. Now, if we reconnect that, oh, what an idiot. We reconnect that power. Now this time, when we turn on our light, You're also going to notice my amp meter, my volt amp meter come on. And in this particular case, because of the requirement of voltage, my amp meter doesn't come on until it gets to about 40 volts. There, I have 79 volts and 1 amp exactly. I've got 79.4 watts, and then there's my energy levels, my power factor. And let's turn this all the way up. Now I'm reading 1.28 amps at full power for that light. What happens if I plug in the heat gun? You should already know the answer to this. My amperage should go up and my voltage should remain the same because I'm only providing that amount of voltage, 123 volts right now. That's all the voltage I have. But my amperage should go up because what controls the current flow through a conductor? The requirement of the load. Look how quickly it jumps. We're now drawing, at 100% power, we're drawing 13.22, so 13.21, 13.24 amps. And we're now down to 116 volts. That's as much as it can handle. So what does that demonstrate? That demonstrates that, again, your amperage is controlled totally by the requirement of the load. Has nothing to do with the solid state relay, which can carry 40 amps of alternating current. But it doesn't necessarily mean that you're going to get 40 amps just because you put a 40 amp controller on there or a 40 amp solid state relay on there. Just means that if you did put 40 amps through there, this should be able to handle it. Let's turn that down. And you'll notice as we turn that down, our amperage and our voltage changes. Now we're only providing 94 volts at 5.5 amps, 5.05 amps. And then we'll, of course, go to 0 and shut it off. So that, viewers, is a way, that is how you add a volt amp meter into your circuit. Now remember, what you have learned here is priceless. This applies to 240 volts, the same thing. It only goes around one lead. Do not put 2 leads in here. If you do, it'll cancel itself out. You only run around 1 lead. This setup works for a variable solid state relay. It works for the SCR. It works for a pulse width modulator. It works for a PID. It works for all of them because it's all the same principle. See, that's the point I'm trying to drive home, is that these principles are so important. Oh, I love it when we get to share. Happy distilling.